Choosing a graph to fit a narrative. Advanced. For each scenario below, choose a graph that gives the best representation. So we'll look at this story problem first. Omar is working out by riding his bike. He starts riding his bike slowly at a constant rate. Then he gradually picks up speed until he reaches his peak. He maintains this peak speed for the rest of the workout. Now, one of the most important things that you have to pay attention to while you're doing these types of problems is how the x and the y axes are labeled. So in this case, in all of the answers, time is the x-axis or the independent variable. Speed is the y-axis or the dependent variable. Okay? So what we're going to notice here is that over time, something's going to be happening to Omar's speed, and we have to decide which one of these matches the story. So it says he starts by riding his bike slowly at a constant rate. So first of all, we know slowly is going to be probably lower on the speed scale than higher. So if I'm looking here, this could be slowly, this could be slowly. This is at the top of the speed, which would tell me that it's fast. So I don't think this one's going to be it. This could also be slowly. Now the next key word is this constant rate. Okay? We have increasing situations, we have decreasing situations, and we have situations where they're staying the same or constant. Okay? So I need to be looking for something like this, where he's constantly going slow. So here, he's at a lower speed and it's constant. Here, he is at a lower speed, but it looks like he's gaining speed, which is not constant, so I don't think this one's it. And here, he's starting at a slower speed and he's going constantly. So I think it's going to be the first one or the last one so far. So let's continue the story. Then he gradually picks up speed. Okay, so he's going to be increasing speed until he reaches his peak. All right, so he's going constantly, and then he's increasing his speed. So far, that one could be it. Here, he's going constantly, and then his speed increases, okay? So that one could be it as well. So let's continue reading. He maintains his peak speed for the rest of the workout. So we know he doesn't go back down, and neither of these go back down, but we want to talk about what maintain means. That means he keeps the same speed. So here, it looks like he's still going fast, but he's going fast at a slower rate. Whereas this one, he gets to this speed and stays right at that speed. We go back to that constant. So this answer would be our correct one, this last one, letter D. All right, so let's do letter B. Lucy is delivering a pizza to Mark's house. She drives at a constant speed towards the house until she hits a traffic jam and has to stop for several minutes. After, she starts up again and drives at a faster speed than before. Now, again, like I said the first time, one of the most important things that we're going to have to do is recognize what our independent and dependent variables are. So time is on our x-axis, and the distance to Mark's house is on our y-axis. We're no longer thinking about speed, we're thinking about distance. So if we think about it, Lucy had to start far away from Mark's house because as time goes on, she's going to be getting closer and closer as she tries to deliver this pizza. So right away, I know that she's going to start high because she's going to be far away from Mark's house, and eventually she's going to get closer to Mark's house. Okay? So if you ask me, this one starts close to Mark's house and gets farther away. So that doesn't make sense because she's trying to deliver pizza to him. Now this one says she's this far away from Mark's house, and then she gets closer and then goes back up. So maybe this could be it, because maybe she delivers it and runs away. So we'll leave this just in case. Now this one here, she's starting far away from Mark's house again, and then is getting closer. So I think that's a good option. Same thing with this. She's starting, and she gets closer by the end. So I'm not sure if this one could be it, but I'm going to go ahead and leave it, and we'll check the rest. Okay. The next one says she's driving at a constant speed toward the house until she hits a traffic jam. So again, we know a constant speed is going to be flat. But this doesn't say speed. This says distance. Okay, so for this one, constant speed was flat. But this one is the distance. So as time goes on, she's getting closer to his house. All right, so this graph tells me that she starts this far away from his house, and for the first 10 minutes, doesn't get any closer. So that doesn't actually make any sense. So it's either that she's going to be getting closer to his house or farther away for a minute. Okay? So I'm guessing it's going to be this one, but let's keep checking. Then she hits a traffic jam and has to stop for several minutes. So if she's stopped for several minutes, that means she's not getting any closer to Mark's house. So here, she's stopped for several minutes and not getting closer to Mark's house, the same as this one, okay? And then it says she starts and drives at a faster speed. So here's a faster speed and here's a faster speed. Now, we have to go back until she's driving at a constant speed towards the house. So she is getting towards the house, which means she's getting closer. So the distance is going from a greater number to a smaller number as she gets closer. So it would have to be this one, because this one gets farther away, and then she stops, and then she gets close. So it has to be letter C here. So the two correct answers are D and C on this one, and you need to pay attention to what are on your axes when you do these problems.